Then coming to the secondary or biological treatment. So this is aerobic process and microbial step. Here the water will come and the air is continuously introduced here. And this particular tank is called as activated sludge tank because activated microorganisms are present there. So this will degrade all the organic material here, and then the degraded material will send down to the next chamber. Here the organic material will come down and removed by this particular sludge removal, and fresh output water would be released there. So in this process, the microbial activity is very, very high, and this can take up to 2 to 3 days as well. And here, in this microbial step, suppose BOD you are getting here earlier was 100. So the now BOD would be reduced by 80 to 90%. New biological oxygen demand would be only 10 or 20. This is an example. This much high BOD you cannot find in the water, but this is what the example I am giving here. In this particular secondary biological treatment, our main purpose is reducing the biological oxygen demand by 80 to 90%. And this process can be repeated multiple times as well. Suppose if you are not getting the desired BOD level, so again you will send that water. So if you look at this particular type, there are two types. One is the suspended type, another one is the attached type. And in the suspended type, we have this activated sludge method. Why activated? Because this activated sludge is again returned to this main tank. It is activated sludge tank. Why? Because this is containing very high amount of microorganisms, which we don't want to lose. So the process would be fast here. So that's why the name of the suspended method, first suspended method, is the activated sludge method. The other methods under the suspended methods we have is we will see in the upcoming slide. For now, there is a few organic reactions which are described here in the activated sludge method. It is organic carbon react with O2, create CO2. Organic nitrogen will create nitrate. Organic sulfur will create sulfate. And organic phosphate will create phosphate. And this will all go about in the atmosphere or maybe in any other source. Second method that we have here in the same suspended method, that is the membrane bioreactor. So the same thing also takes place here, but in the place of settling tank, we will use the membrane modules here. These membrane modules have good amount of air as well as very high amount of microorganisms. So this will degrade the materials here in this place. In this place, more air is added here. This water will go from this side to this side, treated here in the membrane modules, and then again fresh water will go out by the second number outlet you can see here. So this is the membrane bioreactor where membranes are used. Then in the suspended secondary method, another thing we have, treatment we have, is the sewage oxidation plants. Sewage oxidation plants are also called as lagoons. The depth of these lagoons are having 1 to 2 meters. And here the redox reaction takes place. Reduction plus oxidation, redox reaction. So why both? Because both type of scenarios are created here. One is the aerobic part, which is the upper part where oxygen is available. And one is the anaerobic part where oxygen is not available. So in the anaerobic part, the reduction takes place like formation of ammonia, hydrogen sulfide, methane, and this all will come out from the lagoon plant. But here in the oxidation takes place in the upper portion of this particular pond. So this is the aerobic zone. This is the facultative zone. It means both the reaction takes place, aerobic plus anaerobic. And then we have anaerobic zone where only the anaerobic reactions takes place. And the all gases are released here. O2 will consumed here. CO2, CH4, H2S, and H3, that all will released in the atmosphere. So in this side, wastewater is incoming, and this particular side, wastewater is going out. So this is what sewage oxidation plant is. Then the reaction we are continuously discussing, that is the redox reaction. So for the measurement of redox reaction, you can say one word we use very widely, that is the redox potential. Redox potential is termed as P, similar like pH. pH will tell you the acidity or the basicity of the chemicals. The P will tell you the redox potential of the compounds. So redox potential expresses the tendency of environment to receive or supply electrons. Higher would be the redox potential, higher would be the reactivity. Lower would be the redox potential, lower would be the reductivity. Anoxic environment has high P, and O2 is available here for the electron acceptor. So wherever there would be high oxidative reactions you can find out, oxic environment you can find out, that all will have the high amount of P value as well. So in generally anoxic environment, we have the low P. So that is the main key thing in the redox potential. So if oxygen is present abundantly, then P value would be also high. If oxygen is low, so P value would be also low. If hydrogen amount is very high, so P value would be low. If hydrogen amount is very low, so P value would be high, opposite of the oxygen. So, but this thing is important that you have to remember, this is about the H2 gas. And here, suppose we have hydrogen ion. So hydrogen ion will create acidic kind of situation. And if there is a acidic kind of situation, so generally acids are good oxidizer. If I give you example, H2SO4, S3PO4, these acids are having very high amount of oxygen here, and these are good oxidizer. So that's why the acidic environment will create high Pe value and the basic environment will create low Pe value type of environment. So remember that the H2 and H plus ion both behavior for the P change is totally opposite. High hydrogen leads to the low P, while high hydrogen ion leads to the high P. While low hydrogen gas leads to the high P, while low hydrogen ion concentration lead to the low P. So this is completely opposite behavior. So be aware about that they can ask you about the hydrogen ion as well as hydrogen gas, and behavior of both would be different in terms of P. For example, here you can see, select the incorrect statement about the redox potential of the aqueous solutions. So as the concentration of the molecular oxygen increases, the redox potential increases. First is absolutely true. As the concentration of hydrogen ion increases, the redox potential increases. This is also true. As the concentration of molecular oxygen decreases, the redox potential decreases. This is also true. So only left statement is fourth here, which can be the incorrect. As the concentration of hydrogen ion decreases, the redox potential increases. This statement is completely false. So fourth would be your right answer, because hydrogen ion increases the redox potential, and hydrogen ion decreases will decrease the redox potential. So fourth is the right answer here. So this is already asked question in the previous examination. So this can be type of question that can be asked to you from redox potential. So I hope this is clear to you. Then primary treatment we have discussed. Now I am coming to the secondary treatment, or in the secondary treatment we have suspended method completed, and now we have the attached methods. In attached methods, the very first method that we have to discuss is the trickling filter. So in the trickling filter, here you can see these are the trickling filters. You can see trickling means the water is coming in a trickling form from this particular bar, and this bar is continuously in rotation, and this wastewater is pumped through a help of motor and coming out from these pipes or holes you can see here. And here this all water is coming through this particular media. This media is having very high amount of microorganisms which is present here. And this in trickling filter, the filter media, gravels, the gravels are present here, sawdust is present here, and the huge amount of microorganisms are also present here. So this filter media is also called as Julian film. Why Julian film? Because high amount of microorganisms are present here. And this total thickness of this Julian film is about 2 to 5 meter. Slowly, the water will come out from this all 2 to 5 meter and come to this particular effluent outlet zone. And here again the lower portion will come to the classifier. Sludge would be removed. Treated water will go out. Few amount is also pumped into pump, which is not fully curated, you can say, and multiple times this will go again up and come out with the help of trickling filters again for the filtration. So this process will continue, and ultimately from the air vent, air is always added here, and the effluent will go out, or some treated amount of water will go out always. So this is a kind of attached method. So I hope this is clear to you, and what is Julian film and what is the thickness of this Julian film is clear to you, which is very important and the perspective of examination. We have another attached secondary treatment, that is the rotating biological system. So rotating biological system, you can see Here there is a very large amount or this large type of wheel which is present here, and this wheel is continuously in motion. Here you can see round it is continuously moving here, and here the oxygen transfer will automatically takes place because of this movement, and this is one time going inside the water and coming again into the air. And in this way, when it is coming, it is having a biofilm which is having the microorganisms. The air is present in the atmosphere. The water which is attached to it, the microorganisms will eat all the organic materials here, and the water will slowly treated here, and ultimately from this particular side the water will go out. So this is rotating biological system type of reaction. Then we have the tertiary treatment also here. What is the tertiary or advanced treatment? So here very advanced type of treatment methods are used. This step of water treatment is for removing nutrients from the water like nitrate and phosphate, because nutrients are still present there. So this step is not required if water is used for the agricultural irrigation. It is good to have nitrate and phosphate there. You can directly use that water. But if you want to use it for the drinking purpose, household purpose, then you have to remove these nutrients. And the denitrification for the removal of nitrate takes place. In this, the nitrate is converted into N2. Alum is introduced here to remove the phosphate. This will create aluminum phosphate and settle down. And the alum will pure the water. Then we have the carbonation process. This is the process of removal of the carbon material, organic material present in the water. So in the form of CO2, this would be released in the atmosphere. This process is called as carbonation step. So this is what tertiary treatment is. More tertiary treatment are the kind of disinfection type of treatment. So here the very most type of the tertiary treatment material which is used is the chlorine. This chlorine will react with the organic compound and it will create chlorinated compound, which is again carcinogen. So this is not good to use as for the drinking purpose. This is the most common type of disinfection you can see, although this is not good for the health. Then we have three different forms of chlorine that you can see here. This can be chlorine directly introduced into the water. It will create HOCl, hypochlorous acid, and HCl. This is very reactive in nature, very reactive. This HOCl, this would be converted into HCl and a nascent oxygen, and this nascent oxygen is responsible for the killing of the microorganisms or all the causing agents. Then we have the calcium oxide chloride, which is very common form of the chlorine bleaching powder, you can say. It will react with the H2O. Again, it will create calcium chloride, COH twice, and HOCl. The HOCl would again go with the same reaction, and nascent oxygen will kill the organisms. Then we have the sodium hypochloride, that is NaOHCl2. It will react with the H2CO3 present in the water, converted into NaCO3 and HOCl. Again, HOCl will go again with the same reaction that you have seen here, and this is how it will treat the water. So in the all the forms of chlorine that you can see here, HOCl is the main form which is doing its work, and the creation of HOCl is very important here. So I hope this tertiary treatment is clear to you. Another very popular disinfection nowadays is the UV rays, ultraviolet rays, where UVC is used. UV you can divide into three different types: UVA, UVB, UVC. UVA is the best type of UV, which is A for Acha. You can remember that. C is not acha for the human beings. So UVA is a higher wavelength. It is not causing any cancer. This is also coming in the our atmosphere and no problem at all with the UVA. UVB is the uh, comparatively having the lower wavelength and the high penetration power, and this can cause disease like cataract or dermatitis, a skin problem. That is by the UVB 280 320. And UVC is very harmful carcinogen, and it will kill the microorganisms as well. So this UVC is used to kill the microorganisms because the wavelength is very low, penetrating power is very high. So that is UVC 200 to 280 nanometer. Then another thing of the disinfectant used is the ozone or O3. So the O2 is converted, divided into O plus O. That one O is reacted with the O2 and it will create O3. O3 is a very strong oxidizing agent, and the ozone can be used safer as compared to the chlorine because it is not creating any carcinogenic problem in the human beings. So this is the third type of disinfectant or tertiary treatment that we have discussed. Which of the flowing chlorine species is not stable but prepared in situ? It means on that place itself it is created. This is not previously available. That is Cl2, CaOCl2, NaOCl2. So all these are wrong. The in situ created prepared thing which is responsible for the treatment of water, and that is not stable, that is HOCl. It will convert it into HCl plus O, and this O nascent oxygen will kill all the microorganisms. So the C is the right answer for this particular question. This is another numerical problem asked. You have to use the common sense to solve this problem. If a phosphorus limited lake having surface area of 80 multiplied by 10 to the power 6 meter square that is fed by a stream with flow rate 20 meter cube per second that has phosphorus concentration of 0.01 milligram per liter, then the phosphorus leading from incoming stream is. So that phosphorus which is coming from the incoming stream, that you have to just find out in terms of gram per second. So here the options or the questions are in the milligram per liter. Then we have meter cube per second. So how to solve it? So this area is of no use here. This is only provided to confuse it. Why? Because suppose 1 liter water is coming in 1 second, for example, and in 1 liter water we have suppose 1 milligram of salt. And if I am asking you how much salt is coming in 1 second, so what you will do? You will 1 multiplied by 1 and you will tell 1 milligram of salt is coming in every second. The same thing you will do here as well. The flow rate which is provided here is 20 meter cube per second. So in the 20 meter cube, how much liter you will have? So 20 multiplied by 1000 liter, because in 1 meter cube area, you can contain 1000 liter of water. So this is 20,000 now. So 20,000 liter of water coming in every second in this particular lake and having the concentration of how much phosphorus. So that you have to just multiplied by 0.01 milligram per liter. But milligram per liter, here the option are in the gram per second. So you have to convert it into grams. So milligram to gram, you have to multiply 10 to the power minus 3 here. So if you multiply both, so this would be total 10 to the power minus 5. So 10 to the power minus 5 is multiplied by 20,000. So this would be 0.2. And now this is now gram, not milligram per liter. So this liter and liter cancelled. This gram will go upside and this would be gram per second. So 0.2 gram per second is the right answer. That is the second option. This area is of no value. Again, I am saying it has given to you to just confuse you. So I hope this is clear to you. If it is not clear, you can see the solution here as well. 20,000 liter per second, because in 20 meter cube per second, 20,000 liter is coming. And that is multiplied by 0.01 10 to the power minus 3. That is 20,000 multiplied by 10 to the power minus 5. That is 0.2 gram per second. This is how you can solve this. Then last thing, you can treat the water by the filtration. The filtration can be also of 4 different types. The very first type is the particle filtration. And this, the particle size which is removed is 10 to the 10,000 micron. So soils and particles are removed here. So very large particles are removed here. So this is particle filtration. Then we have microfiltration. The filter size is 0.1 to 10 micron. Bacteria you can remove here. Then we have ultrafiltration, 0.001 to 0.1 micron. Colloids, viruses, dissolved organic compounds can be removed here. And then last we have the reverse filtration or reverse osmosis, RO. And here you can remove all the colloids as well, 0.001 micron, all the metal ions, aqueous salts can be removed here. So particle size and for what purpose these are used and the type of filtration is described here, which is very important in the perspective of examination. So remember this table carefully. Then what is the bioremediation? Bioremediation means remediation. Remediation means release, or you can say some kind of profit or some kind of relaxation you are getting. That is the remediation. So that relaxation or that profit is if it is provided by any biological agent, bio. So that would be called as bioremediation. So removal of contamination with the help of microbes is called as bioremediation. The disadvantage here is the large scale is not possible because large amount of microorganism or the bio thing is required here. Only biodegradable compounds can be used here. If any compound is non-biodegradable, for example, plastic, you cannot remove it with the help of bioremediation. The another disadvantage here is only specific microbes you can use for the specific type of pollutant. If you are introducing any other kind of microorganism or any other kind of organism, so it is not going to degrade it. So that way it will take long time, very large time is required here. So these three all are the disadvantages related to the bioremediation. But otherwise, these are the environmental friendly and very good type of decomposition you can say as compared to the other types. This bioremediation can be also done in two types. One is in situ, another one is the ex situ. In situ, you introduce the microbes in the same place. You are not taking your wastage to other place, that is in situ. In ex situ, the treatment will take place in other new place. You have to just take that all material to new place, the wastage, and then you can treat that there. So that would be the ex situ. Or by another term, you can understand it by introduction of the microorganisms. In situ, microbes are already present, and the wastage of the decomposition of the wastage automatically takes place. In ex situ, the decomposition rate takes place by introducing the microbes from any other new place. So that is the main difference between ex situ, in situ type of bioremediation. Here, the all different types of bioremediation methods are simulated here. The first type is the in situ method. In situ method, we have the biostimulation. So as in the name itself, this is biostimulation. So you have to add the biotic agent or the microorganism so that is induced or stimulated by just providing nutrient and oxygen. So that would be called as biostimulation. The microorganisms are already present there in the soil, in the groundwater. No need of the microorganisms introduction here. Only you have to provide good amount of oxygen and good amount of nitrogen. That is called biostimulation. That is also of two types. If it is taking place in the soil, that would be called as bioventing. If it is taking place in the groundwater, that is called as the biosparging. Then bioaugmentation. Bioaugmentation, microbes are introduced from the outside to the new place. But here the wastage of the same place is kept in same place there. So that is what bioaugmentation is. Only microbes are introduced here. The wastage is of the same type or same place. Then we have XC2. XC2, you have to take that biodegradable waste to a new site for the biodegradation. So if we are taking it to new site, so that would be XC2. So first method here is the land farming. So you are taking any land and you are farming there, farming of the wastage there. So that is land farming. Then biopiles are created here, and then microbes are introduced to degrade that. That is the biopile method. Then biocomposting is also example of XC2 method where the compost is created. So that is the biocomposting. And we have another term that is the phytoremediation. So as in the name itself, you can see this is phytoremediation. So phyto means that is plants are used here. So if any plants are used and remediation is taking place, so removal of pollutants through the plants is called phytoremediation. So these all is the different types of bioremediation. I hope that is clear to you. So this is all about the water pollution. Water pollution chapter is now completed. And in the next class, we will start the air pollution. So noise pollution we have completed, thermal pollution we have completed, and water pollution we have completed. And groundwater pollution also we have completed in the same chapter. The next thing, air pollution, we will start tomorrow and we will finish that unit in 2 days or 3 days also. And then air pollution, water pollution, all the different types of pollution would be completed, and all the 6 unit would be also completed. So meet you in the next class.